Welcome to Networking Field Day 14. We are here at Juniper Networks. The presentation that you are about to watch is being attended by an invited group of delegates who are here to ask questions, make comments, and offer their opinions about the technology and solutions that Juniper will present. If you'd like to learn more about this event, go to our website at techfieldday.com. Check out our YouTube channel at youtube.com/techfieldday.
All of the talk so far was about how do we enable access to our software, our network elements through standards-based models and standard protocols and such, right? So great for multi-vendor and everything else. But there's a bit of a challenge because we don't have that level of standardization for everything that we'd like to do with network devices today, right? At some point we'll get there. But what do you do in the interim if you want to customize your box to offer something that your competition doesn't, right, as a customer of ours? If you want to do things more efficiently and there isn't a standards compliant way of doing it, you can wait for the standards to evolve, or you can use what we have developed internally, the mechanism called JET, right, Juniper Extension Toolkit. And what this is really, there's a number of different elements inside, but the key element is APIs. So as Nitin pointed out, we have built our software now. Over time we have been modularizing it and we've been adding APIs to each of those modules. This is another view of how you would look at a network element. You look at it as comprising of three planes: the data plane, control plane, and the management plane. And we are providing API interfaces to each of those. Now OpenConfig, IETF, Yang models and all of that almost exclusively focuses on the management plane. So you can think of them as a way of interfacing with the router or a switch through a management plane. There aren't any really strong standards that have emerged around exposing control plane API directly, right? So routing protocols, for example, there isn't an API for that. However, internally what we do is when we design our software, our daemons communicate with each other through an API mechanism. What we are doing now through the JET program is actually exposing the same API to third parties. So the goal is, if someone wants to develop applications and features on Juno software and they don't want to go the configuration route, they can actually develop it just like we develop features, right? So that's the whole intent behind JET. Data plane API we haven't publicly released them yet. We'll do that at some point in the future. But right now we have a pretty rich control plane API in addition to the management plane API that we have. And these are the categories that we have, right? So we can inject routes, delete routes, edit routes, interface creation, etc. on the router can be done directly by means of these APIs. This is shipping. Right, again, I made a point in the beginning, everything that we are talking about here in terms of demos and the actual capabilities here is in shipping code. It's been out there for at least 4 to 5 months now.
Those things right there are all management plane. So routes, interfaces, firewalls, the getting models, all we've been talking about. What is the potential thing you could do with a control plane? What's the practical application of having access to a control plane API?
Right. That's a good question. In most cases, the management plane API is going to be just fine, right? You may not even need to do this. But there might be certain operations where you dynamically want to go and inject state directly into the routing control plane. A loose example that I can give you as an analogy is perhaps something like OpenFlow, right? Why do you even need OpenFlow when you could just tell the router what you want to do and create the kind of network traffic patterns that you want by using the traditional mechanisms of configuring something, going to the control plane, and then down to silicon.
Wouldn't that be modifying, RIB or FIB?
Yes.
That's what you said though was at the bottom of the chart of not
Correct.
having direct access to yet. So I guess I'm trying to, what's that middle layer actually give us?
Yeah, so this allows you to go into the control plane. So if you look at how configuration works, whenever somebody configures a route, it first goes through the management plane where all the audit checks and verifications and all of that are done. So that's the management plane. Then it actually goes back to the control plane because that's where the RIB entries have to be updated and such. So it's the routing control plane that's typically in a router running on a dedicated route engine, right? That's where it goes. And then there's a rib to fib translation, and finally it goes down to silicon.
Gotcha.
So there's 3 steps.
So we could manipulate rib, just not fib.
Correct.
Okay.
That's exactly the point. So fib, you could do things like open flow if you had direct access to the fib and silicon, right? Or you could come through the rib. So it allows you to do bypass on the management plane, and that has some performance improvements potentially, but also it gives you some additional flexibility because you could do things that you might be constrained with a management plane API. Now the thing is, over time the management plane API has become so rich, because that's almost exclusively how everybody deals with devices today, that most of what you need you can get by with that. But you have a lot more tools underneath if you are willing to play with the control plane, and that's what we do, right? Internally we do a lot of feature development, and we use this API internally, and now we are offering that to the brave souls who want to play with that too.
That's what I was thinking.
So
Yeah.
for the even braver souls, what's the timeline for the data plane API?
Timeline, we've been working on a prototype with with internal teams and some partners, but I'm not sure I can disclose a timeline just yet on when that will come.
No, I wasn't expecting roadmap. I was thinking, are we talking decade, 5 years,
No.
1 year?
Months to a year, maybe 2 years time frame basically, but yeah, it certainly is not that far out, because if you think about this, we have been using this already internally, because we develop silicon ourselves. We also get silicon from others to build some of our products, and then we build Juno software on top of it. So we have always been using a layered API driven approach to talk to our silicon. The question is, now if we have to expose it to the outside world, there's a lot more work we have to do in terms of providing the right packaging, tooling, and all of that. And we just want to make sure we do it deliberately in a fashion that is actually usable for others.
Okay, thank you.
The API themselves, the framework that we have established around it, so these, we will provide SDK kits to, actually we have already provided SDK kits that you can go and download. We publish interface definition files for these, so you can take it, and then in frameworks like Thrift, you can actually generate any kind of APIs in any languages that you want to, you can convert those APIs to any languages that you want to actually write your code in. So there's really no limit to what kind of language support there is with these APIs. The good thing is the applications that you develop, they could work on the box on a Juno's device, just like we have features running on the box, or they could run externally as well and talk through things like gRPC and back into the box, into the control plane, for example. This is just a little more detail on how the process works internally. You really don't have to ever worry about it, but we just wanted to show you how it works. So you could develop the app. It uses the API underneath, the Juno's Extension Toolkit API. It could talk through standard protocols down to Juno's software. And what happens when an API request comes in is it's intercepted by a broker on our end, which then decides which actual daemon at the back end to farm it out to, right? So, and then these are all internal Juno's processes, Juno's daemons, which actually do the processing. So any route related API, for example, would be consumed by the routing daemon here, and so forth, right? So this is just a very high level picture of how the API architecture internally works. Again, for the most part, most people will not even have to do this, but it's something that's there. I don't think too many vendors have really exposed this level of APIs to the outside world, and this really almost ties back to the vision that Nitin was talking about, where it's part of the process of cloudification of software, being able to expose our interfaces to third parties, interoperating with third-party software, because there's a benefit for Juniper as well in doing this, because we can take third-party software, open source software, and we've done that for some of our production customers very recently using this infrastructure, where features we did not have but were available in the open source, we've actually integrated them with our software using this API framework. So it just accelerates the pace at which software and features and development can happen, not just from Juniper, but with the ecosystem as well. Okay, so any questions on this? If not, we can switch over to a demo here. Go ahead.
Is there any kind of or need for authentication or authorization mechanism?
Yes. So absolutely. So all of the applications that you actually develop, they need to be signed to run. So as part of the workflow, there is a signing step required to make sure that somebody is not doing, developing something and maliciously adding it to the router. And then the communication channels itself, if you're using gRPC, it's HTTPS underneath. Netconf uses SSH underneath. So there's secure communication between the application that may be running outside and the box. And if it's running on the box, it needs to be signed, right? So
is there some kind of certificate infrastructure that needs to be in place to have this exposure?
Correct.
Okay.
So we have a process, and I don't have it here, but on our JET web page that's posted on juniper.net, there is a workflow and it describes the signing process as well. What you need to do if you want to run an application, what's the signing process behind it?
As I listened to some of your questions, earlier you were asking about the Yang models and how does that work its way up and stuff like that. And then what's the point of being able to access the RIB and all this other stuff. So for somebody like me who is not, I've been a network engineer, right? But I also do software engineering, solutions development, and things like that. The purpose of a lot of the things that are being built into these devices is so that somebody like myself that's out there trying to build some sort of solution, overarching solution that takes care of all this, if we follow standards and we have things like APIs that allow us to inject state rather than having to change the configuration, or if we have those models that I know when I interact with a device, regardless of what it is, as long as it follows that model, I don't have to worry about that stuff anymore, right? It makes it much easier for me to get something built and running in a timely manner. And then that way, this solution or whatever it is that we build on top of it, now the person that's running it or looking at it can specify the state of what they want, and we take care of injecting routes or policy or something like that. And we know that when we pull the information back, as long as it adheres to the model, we know what that model is, we can read it, right?
I guess in my question is just trying to understand the motivations. There's probably a line here I'm going to try not to cross, but it looks to me a lot like white box switching by exposing RIB and FIB and allowing someone else to be able to modify those things outside of your own operating system.
Right.
And so, we're not seeing any of the incumbent network vendors, right, doing that. And so I was trying to understand the motivations about why and how you're opening that up, how we could possibly use it.
Right.
Because you take it to its full extent, and someone could bypass all of, your management components,
Exactly.
install what they want on top of it, and essentially have a Juniper-based white box switch. It might be a lot of work, right? You know what I'm saying? But
Yes.
I want to understand what your motivations are in doing that, because maybe there's something I'm missing in how you're developing. Because I can understand having the APIs open to yourself to be able to,
Exactly.
develop new applications and do those things, but opening them up to the world,
Right.
has implications, and I'd like to understand, what the reason you're doing that is.
Yeah, that's a great question. And there's two things. First of all, regarding the white box question, right? Actually, our Chief Development Officer, head of our Juno's development and innovation, Jonathan Davidson, over a year ago, he's already said that we are happy to be providing white box software or hardware, right? We are participating in OCP, etc. So that certainly is not an issue as far as Juniper is concerned. What we want to do is, in conjunction with that, we also want to make sure that we have hooks into various layers of our software, because there's not I would say a lot of customers have come to us and said, hey, can we use your stack for the most part, but integrate this particular application alongside that or into that, right? There's been a lot of industry questions around, hey, can we just get your silicon and run our software, or vice versa? Can you just give us your software stack and run it on this box? Which, by the way, we do, right? We do have merchant silicon boxes that we support as part of our switching and access portfolio. But a lot of questions have been around being able to customize with things they write or things that are available outside. And so this is an effort to make sure that those hooks and APIs are available if customers want to do that kind of thing. It adds value to them, it adds value to our software as well, right? But full white box route, I think we've already said that we'll go that route, and provided OCP participation and such as well in conjunction with that.
It's a great answer. It's exactly what I was looking for. I was wondering if that was the direction you were heading. I hadn't
Yeah.
heard that, so I appreciate that.
So this kind of opens the door to almost a hybrid SDN where you can have your traditional network as your baseline, and then instead of building everything from the ground up as an iterative process, you have your baseline and then tweak what you need, adjust what you need as you go, and then fall back to standard.
Yes.
Okay, thank you.
Yeah, you don't have to use any of it if you're not looking to do any kind of customization, right? You have all of Juno software doing that for you. But if there is some secret sauce application you've written, you want to do things in your network a little differently, then you have all of these hooks.
Okay, so what I'm going to do is I'm actually going to talk about setup for this JET demo. I'm not going to show you how to run the demo because this is a little bit more intense than the streaming telemetry one. But I'm going to talk about what the demo is, why we built it, and what it actually does. So this is something that we actually, well, the font's really small on that. We actually built this for a customer, and they're a global satellite service provider. And what they do is they provide connectivity for vessels, and those vessels can be ships or tanks in a battlefield or something, right? So anything that they can use that satellite for to give them connectivity. And in this particular instance, we were using some MX480s, and ACX devices were out on the vessels themselves. But between those two, they have modems that talk through the satellite. Okay, and those different sites can actually move. So they can cross across a particular beam within a satellite, and while they're in the middle of that beam, they're getting good connectivity or something like that. But as they get to the edge of that, or if there's inclement weather or something like that, it can change the status of that beam and the device or the system within that beam. So what we needed to do was be able to dynamically detect that degradation of service was actually happening, and make sure that whatever vessel was out at the edge of that beam or had the inclement weather wasn't trying to gobble up more bandwidth than it needed, and it wasn't actually changing. There are two tiers to these types of vessels. There was a tier 1 and a tier 2. We had to make sure that the tier 2s weren't trying to steal bandwidth from the tier 1s and things like that. We didn't want to do any hard bandwidth limiting. And you could have several classes of traffic to each vessel as well. So you have to have quality service for each one of those classes. Any particular status of one vessel should not affect any of the other vessels. So if you have the one that's out on the edge of that beam, it should not be affecting any others. And we should be able to control that through routing and the class of service. And it should be not only applicable to just the satellite modems. If we have something else that's connected to an MX, we want to be able to detect that same type of degradation, even if it's hardwired or something like that. So they wanted to make sure that it wasn't specific just to those modems. So this is a basic construct of what it looks like. At the top you have the MXs, and there's a server connected to them. We could run this JET application on a server or on the devices themselves. In our demo, I'm going to show it to you from the server side, but you can actually run the same code on the MXs. So you don't have to have a separate server if you don't want to. And then there's site modems that are connected to these MXs. And that's where we're getting the information from into the application to decide how to change that class of service on the MXs. Those site modems communicate across the satellite to those moving vessels, and they have modems on their side as well. And then on the back side, they had the ACXs, which provide the routing and connectivity for whatever's on that vessel.
The Ethernet handoff from the modems?
I'm sorry?
Ethernet handoff from
Yes.
the modems?
So for the application itself, you have to have some sort of configuration file that specifies each one of your sites. And there's some things in there that you need to know: what the name of the site is, what interface is the ingress interface on the particular MX that it's connected to, so you know which one to change, that type of thing. And you can also auto-discover a lot of that if you needed to, but we just have these configuration files that we build and put on there. Then you also define the polling, because what we're doing is we're actually asking the site modems via SNMP for the information that we need for particular OIDs. The main one is this mod cod, which means modulation and coding for those particular modems. And that's part of the information that we're going to use to determine and calculate what the CIR, PIR, those types of things will be.
And this is in production? Or is this a test case?
No, this has been piloted. I don't believe they've rolled it out in production yet.
Okay, I'm just curious because this is so much into my world. One of the things I do is design for wireless ISPs.
Right.
And so when you're dealing with commercial RF links, just like satellite,
Right.
rain fade and demodulating a link is a huge issue in your QoS architecture. So, we've looked at a lot of different solutions, but this is a really intelligent, fantastic way
Right.
to combat that problem, because in commercial RF, this is a serious problem.
Yeah, absolutely.
We have
So
the other one where they're fixed points. They're not vessels moving around,
Correct.
but
Right,
that exact
it's the
thing.
same. Yeah, it's basically the same RF engineering principles in the
Yeah.
rain fade and the capacity issue.
Right. So what this essentially is doing is monitoring and making changes directly into the policy about what the bandwidth is and everything like that.
Yeah, I know a lot of WISP guys are going to be really excited to see these pictures.
Okay. Well, you can share them with whoever you want.
I've already shared them. They're already out there.
And then we also have to define the configuration template of the things that we're going to change, okay? And this configuration template is not a Junos configuration template. This is just the filter template that we're going to apply to the interface itself. Okay, so how this actually works is the JET app will run on a server for us, and it will poll the modems in 10 seconds intervals using SNMP gets to get those particular OIDs that we had configured in that configuration file. If it's not reachable, the JET app will tell a higher level OSS or NMS system that it can't get to the modem. That's another problem that we can't solve with this particular application. These are looking great here. All right, so if it can get to it, what it does is it retrieves the information and it calculates the new CIR and PR based on that mod cod and a few other items, only if they've changed. If they haven't changed, it doesn't have to do anything. The new computed values will be applied to that ingress interface that's specified in that configuration file. And then the JET app will verify that the changes actually occurred too. You can't just push it and forget it. What it does is it verifies that it's there. If it is, it updates its own configuration file because it uses that to determine what is it supposed to be. Okay, and that's what it does there. It overwrites that CIR and PIR. And then it'll go back into a wait state, wait for 10 seconds, do the poll again. Okay. Oops. So with that, I will show you the demo.
And before you start the demo, I've got a question from Twitter.
Oh, sure.
So is there a mechanism to detect errors in the automated application of config and rollback on all devices programmatically?
I'm sorry, could you?
Is there a mechanism to detect errors in the automated application of config when you're pushing out configuration automatically? If there's an error there, can you programmatically roll back? I think is the question.
Yes, so they're asking about programmatically pushing a config, not that particular config.
Right, yeah, a config.
Oh, yeah. So we have the,
And also to roll it back if it turns out there's an error somewhere.
yes. So, funny you should ask that. Netconf does that for you, right? It will, there's two ways. We have the commit check that you can specify that if programmatically over netconf. So you could say, just run the check on this, make sure it's syntactically correct and everything like that. And if it doesn't return any errors, then you can feel pretty good about saying commit it. You can do a commit confirmed, which says, if I did mess something up, roll back in 5 minutes or 2 minutes or whatever automatically. And you can also have netconf or over netconf commit it, and if you get an error, well, it wouldn't have committed it if it got an error. But let's say you see some sort of connectivity problem later, or within seconds after you do a check or something like that. So the configuration committed okay, but you need to roll it back, you can issue a netconf command to roll back the configuration, and it'll roll back to the previous one, or the previous 30 is what we have on the device itself. So yes, you can do all of that programmatically.
Thank you.
Okay, so we're going to run the Python application itself. And the first thing it's doing is it's going out and it's taking the information from that configuration file that I spoke about, and it's actually applying that to the interfaces themselves, those policies. Okay, so what we're doing is we're going to the first MX, and we're checking to see, this is going by pretty quick here, we're checking to see what type of filters are actually on that interface. You would not see any of this in the configuration because we're using the JET APIs. What we're doing is we're actually applying that filter directly to the interface itself. Okay? It's not through configuration. So if we do the show filter, you can actually see down at the very bottom, this is the one that we're going to be messing with the most here, filter S4 for site number 4. Okay? So if we look at the actual information that's inside that filter by looking at it through the index, we can see here that the bandwidth limit is set to 24 meg. Okay, and that agrees with the pulled data that we asked for through the application itself. So now what we're going to do is we're going to go over to site 4, and we're actually going to artificially change that modcod value from the default of 12 to 1. What should happen is every 10 seconds we're running this polling through SNMP. When the application sees that that's changed from 12 to 1, that value, it'll go back out and recalculate the committed information rate and a few other items and put those back into that filter, and we'll see that. So we've artificially done that, and we can see right there the modcod for site 4 is actually 12 since the last time we polled. We're polling again, and we'll see that now that modcod has changed to 1, which is what we pushed it to do, and we modified the committed information rate to 6 meg automatically. And if we go back and we look at the filter, it is indeed 6 meg now. And that's it. So every 10 seconds, it's going to go out and do that poll, check it. If it needs to be changed, it'll change it. If it doesn't, it waits another 10 seconds. Any questions? So anybody that's ever looked at a configuration that's very large on a Juniper box, committing it isn't the speediest thing in the world, right? Well, what if it takes 10 seconds to make a commit? You have hundreds of thousands of lines on that MX. You've gone through the next polling period. So this way, this happens instantaneously. It's not in the configuration, so we're hoping that you're sending valid, sane commands through JET. That's kind of interesting. Wasn't expecting that. So we're hoping that that's what you're going to send. Okay, so you can actually.
So this is an out-of-band telemetry. You're creating packets that flow over the link, and you're creating probes that do that. You're not doing in-band monitoring here, application monitoring.
No.
Right.
No.
So ping or get or whatever. How sophisticated can the probes get?
It's as sophisticated as you want to make them.
Right.
Right. I mean, with the APIs, you can write the probes however you want them to be. So if you want it to be resident on those modems, you could actually make that happen too if you wanted to.
Is there any way to query like the actual RF file layer in the radios? Is that anywhere in the neighborhood of the solution to be able to look at my modulation on, QSPK or QAM64 or anything like that?
Is that information that we can get from SNMP?
Some of them you can, yeah. Some of them it's available. The modulation is in the SNMP.
Yeah. So in this case, all you would do is you would add the SNMP OIDs that you want to query. Now you'd have to write some extra code within the application itself to deal with those.
Right.
Right. So anything that you can pull.
Right.
From that, yes. Now, if it's something that's only CLI based, or you have to use an EMS or something like that, then you're talking about another set of code. Maybe the EMS has a REST API. You could write that in there. That kind of. But anything that you can pull, yeah, you should be able to use. Yep.
Yeah. Okay, that's cool.
Okay. So I'll just summarize, right? When Nitin started out, he began by laying out the vision of where we are trying to go as a company, right? We've always made really good silicon. We've had a really good networking stack. That's always been our heritage. So we've got a lot of great software. Now, how do we take those assets and bring them into the environment that is relevant today, right? And so he talked about principles of modularizing your software, being able to adopt cloud principles. From an automation perspective, we laid out the vision of what we are trying to do. What's the beacon that's guiding us in terms of building self-driving networks. But what they say about vision without execution, right? So this is what we are trying to do here, is make sure that as we march towards that vision, we have all of the right building blocks that are available today, and incrementally going down that path to allow our customers to take our software and do interesting things with that, right? If they choose to do it themselves, be able to customize it, be able to build interesting things with our software and our platforms, but also make sure that our platforms are built in a manner that interoperate very easily with third parties, interoperate with controllers and orchestrators. There's a lot of actual motion now on the other SDN, right? So we want to make sure that our products interplay very well in this ecosystem. So these are the ways we are trying to move along, like move this curve altogether up, not just stay along an incremental path where you improve efficiencies but then lose out on agility. We want to move that curve upwards by doing things in software. It's very easy to understand this curve when we talk in a hardware context. For example, ASICs are really efficient, power efficient, performance efficient, but not as agile as maybe general purpose Intel CPUs, right? But the same dynamics apply in software as well, software infrastructure. And that's what we are trying to move forward by coming up with model-driven mechanisms to interact with our devices, by having machine-to-machine protocols, we talked about all of those, by providing API, standards-based and our own, to be able to do interesting things with our software. And I hope the demos today and the talks gave you a bit of a flavor of where we are going with this, right? So that's all I had to say. If you have questions, if you have any feedback for us, either as a follow-up for today's session, or if you want to play with some of these things, you can download. As I mentioned, we have VMX that you can download, and it has all of these capabilities. Try it out. We'd be happy to hear back from you, because we are trying to work together with the community also to drive this forward. So any feedback would be much appreciated as well.